Okay, this is our second lesson on probability. We're really continuing with the first learning goal. So we're just still working on concepts and notations. And so we're just going to see some more examples today. Learning goal is working with basic terminology, learning about N of A and N of S, and then we're going to look at what we call the indirect method today. So I actually want to start really kind of explaining some of the definitions through this example. And so here you've got our favorite Thomas the Tank Engine train, James. And so James actually is a really good example of a probability because James is equally likely to travel any of these four. He's just a little wooden toy. So we're not really sure how his wheels are going to go, and he's really equally likely to go to any of these four pathways. So the question is, determine the probability that he does not take the fourth path. And so to paint some of the notation that we had before, because that's really the focus of this, what we would say is that the sample space is the different pathways. So pathway 1, pathway 2, pathway 3, pathway 4, and so that's all of the different ones. N of S would actually be 4, because there's 4 elements in that set. Not taking the fourth path, we would actually call that A. So A is not the fourth. And so we're going to use different letters like A and B for different things, but the goal is to find out the probability not the fourth. The element A is actually equal to everything but the fourth pathway, so pathway 1, pathway 2, and pathway 3. And so what that means is that N of A is actually going to be those 3 ways. And then P of A would be N of A divided by N of S, which is 3 over 4. And so that's how we'd figure out the probability. Now this idea of not the fourth path is written this way on purpose, and so that you kind of think about how are you visually imagining not the fourth path. And so what we're going to call this is the complement. And so A complement, or A apostrophe, is actually going to be everything we don't want, and so it's the fourth path, which is like pathway 4. And that is equal to, that has a value of 1. And you'll notice that the relationship between N of A and N of A complement, so this is N of A and this is N of A complement, they're supposed to add up to N of S. And so these are all the things we're going to look at today. So I want you to ask a question like this. So see if you can kind of write down what S is and what A is for something like this, not a face card. Not a face card really just means, and you can think about it like this, as a number card. If you're not sure about cards, a quick Google search will tell you, but a number card goes ace, 2, 3. It's everything except for the jack, queen, and king. So that's not a face card. And so you can think about that question. In this example, the sample space, S, and we really should have a capital S there, but is all possible cards. And so N of S is 52. A are the number cards, the things that aren't face cards, is 40 of them. A complements, these are just definitions, is everything not a number card, so the face cards, so there's 12 of them. And these two things will add up to N of S. That's always true. And notice that it might have been easier just to figure out how many face cards there were rather than how many number cards, and that's the reason why the question was given that way. And the probability of A, which is what we want, is 40 out of 52. Reduce to 10 out of 13 as a fraction. You can also put it as a percentage. Just a visual way to look at it. So you can imagine this rectangle is the world of cards, so all the cards are in the rectangle. A would be the number cards, and A prime would be the face cards. A complement would be the face cards. And with this, we actually know that with the complement, P of A and P of A complement, they actually have to add up to 1 or 100%. So this is what it looks like in the example. So we just made the circle a little bit bigger for you. There's 40 not face cards or number cards, 12 face cards, and then 52 total in the rectangle. And you'll notice that these two things, A and A complement, they add up to everything. Somebody asked me, why is it A complement? And so, and really what a complement means is everything, like when somebody compliments you, like think if you play on the same team, they might have the skills that you don't, you have the skills that they don't. It's really like a compliment. You can also think of it in fashion, like the opposite of that shirt and those pants, they might complement each other because a lot of the things that, a lot of the traits that the shirt has, the pants have, that the shirt doesn't have, the pants do have, just as a kind of a fun example. And then there's some questions today to practice. And again, these questions would show up, just those questions for you, and you can share those to the discussion forum.